Great pleasure to be here. I'm pleased to say I don't have any slides, and I didn't prepare, but that's kind of the art of communicating, right? You just show up, and whatever I say, I don't know what I'm going to say next, but I'm just going to tell you the story. So yeah, I've been moving in different worlds. I'm a quantum scientist by training, and I do a lot of stuff with quantum mathematics, physics, chemistry, applications. At the same time, I'm also responsible for building a quantum innovation ecosystem in Calgary and region. So we have significant investment from the University of Calgary, the province of Alberta, and then various programs in the Canadian government to build that. I also do a lot of work with startup companies, so quite a few startup companies, both successful and unsuccessful. I played a role in, and that's helping startups know what the opportunities are in, I should hold it closer, what the opportunities are with building a business in an area that is colored by being both emerging and a dual-use technology. So there's the complexities, and then I do, I'll stop talking about what I do in a moment, but I'm also doing technical due diligence for companies and for investors. So some of the investors that are, let's say $20 to $50 million scale investments, they like the technical due diligence. So I'm doing that aspect too to help investors know what they're putting their money into. I can say that they usually don't listen to me, but they want my opinion, and then they'll do what they're going to do. And then I do stuff with nations, and I've also had a lot of international involvement, helping behind the scenes in the Indian strategy. I also played a role, which it's got me in the bad books lately, but with China and the China policies and development and various other places. Okay, so that's just amplifying what Doug said, that I have to do a lot with communicating to different stakeholders, users, etc. And a lot of what I do, I try to be an honest person when I communicate. So I like to believe that after a quantum scientist dies, there's quantum heaven and quantum hell. And in quantum heaven, there's people like Dirac and Feynman, and quantum hell is all the people who say things that aren't right about quantum. And so I try to live my life, so whatever I'm telling you is always honest, because when I'm gone, I'm going to go to quantum heaven. But if I oversell and I hype, then I'm going to spend eternity in quantum hell. So that helps me be honest. Okay, so now here's the issue when I'm communicating quantum, just from personal experience. So I've spent a lifetime doing it. So we're doing quantum research at various levels for 40 years now. So I feel, as the famous saying, Feynman said, I think I can safely say no one understands quantum mechanics. And it's very true on a philosophical level. So I also don't understand quantum mechanics, but I feel like just by living on the planet as long as I have, I understand it as well as other people. So I don't really understand it, but I feel like there aren't that many people who understand it that much better than I do. Now, if you get into particle physics, things like that, they understand better. But basic quantum mechanics, and that's what underpins the current era of quantum sensing, quantum communication, and quantum computing as the so-called quantum 2.0, the quantum revolution for the 21st century. Okay, so the first rule is quantum mechanics is really hard, and we can't pretend to convey all the issues of quantum mechanics. We don't even know fundamentally quantum mechanics is right, which always puts up this interesting issue. I'm on a standards body, the JTC3, which was actually launched last year here in Seoul. So South Korea plays a key role in leading the standards development for quantum. So we can't be entirely certain quantum mechanics is right. This has various implications. We talk about quantum providing safe communication. I believe if all the principles are met, then we do provide the safe communication, but we can't prove it. There's always the chance, because of this competition with the theory of gravitation, that quantum mechanics might have to be modified, and that has interesting implications. Other weird things, like if you want to operate your quantum computer while you're dropping into a black hole, I worry about these kinds of problems, and et cetera. So all these issues come up. This said, the field is really complicated, and then what's happening now is we paint quantum stuff as being kind of ushering in the new era, both in civilian and in military applications. So without totally understanding what quantum does, people are making multi-billion-dollar decisions and larger based on precepts that aren't entirely clear. Then what does happen is we have a lot of communication going on through ways sometimes suspicious, like it's not every communicator knows everything they're saying, and not every communicator is honest. And so it's kind of swimming through this sea of danger in communicating. So the issue really for communicating is make sure that we set up certain short statements that are factual, that are defendable, that convey what quantum mechanics is. I gave a talk here a couple days ago at the Quantum Korea meeting in the OECD section, and I'm very careful of what I do. I'm not sure I'm understood, but I explain quantum mechanics underpins everything. It's kind of the constitution by which all laws of the universe are created. I try to get across that the wave-particle duality is fundamental. If I have more time, I go into how wave-particle duality is then why that offers an advantage, why that duality underpins the beliefs about security, why that duality can give advantages, disruptive advantages potentially in solving certain kinds of computational problems, and why sensors have limits due to that principle and how to circumvent it. So the idea is always to have very simple cases. The danger is always people get impatient. They say, well, I don't want to know all that. Just tell me what it's good for. When will I have a quantum computer? What problems will it solve, and when will it be? And then the pressure builds. You kind of like, I feel like sometimes I'm being bullied. People are saying, okay, fine, but get to the point. What will a quantum computer do in 5 years? What will it change? Will we be able to solve a nuclear fusion problem in a quantum computer so that we move away from uranium-based or plutonium-based nuclear energy and so on, and we go to fusion and we use seawater and there's no pollution in the world? And then it takes a lot to resist that you have to then say, look, we really don't know. I'll tell you things, but it's just wild guesses based on assumptions that I can't defend. But this is kind of the risk with communicating, is there's a huge pressure where people want to know, and this is normal human nature, kind of saying, what will quantum do for me? How will my life change? What will be different? Will there be new medicines? So that's a hot topic right now with pharmaceutical companies. So we try to create a pathway that says there are hard problems in chemistry that if we can deal with those on a quantum computer, then we can solve problems about binding and affinity, and then be able to design drugs cheaper and faster by doing them, we say in silico for on a computer, but quantum computers don't use silicon necessarily. So it's kind of in a quantum computer. But there's a lot of questionable assumptions along the way. So I don't have any answers for it, but often when we're communicating what we're doing with quantum, it's the reality, and I always try to get it across, that I myself, working in the field for 40 years, don't really know all the answers. There's a lot of things I don't know, and I do research to figure out, and then we're on the spot where we're developing a technology that is potentially disruptive. It does change the ground rules for computing. The basic idea of bits, binary digits, zeros and ones, and the logic no longer apply. In the sensing world, there's a way of trading off noise if you know what's going on, and so in pathways like gravitational wave detection, in their technical roadmap, they want to make use of it. And so this is the challenge. But part of the challenge is getting across saying, like for me personally, I say, I convey I'm an expert, I convey I don't have the answers, and that sometimes in life you have to make billion-dollar decisions without knowing the answers and not always knowing the questions. So that's my lesson for today.
Brilliant. I've got lots of notes which I'm going to